if you're traveling in a circle, right? So let me just draw a circle right here. We can't really define this using linear kinematics because circles don't have corners. They have curves, and we can't really use linear kinematics to describe this motion on a curve by itself because it's just for objects moving in a straight line. So what we can do is to best approximate that is that we could take the tangent on off the circle to describe its motion. Like this. And basically what it's this is saying that we can describe this motion in a circle as its tangential velocity. So this is how we can actually describe things in a circle linearly, but we can also describe them with rotational mechanics. So what you should recall is something with angular speed, which is the same thing as 2 pi times the frequency, or 2 pi over the period. Now, if you recall from circular motion, the period is how long it takes to complete one revolution, and the frequency is how many revolutions you can complete in a second. So we know that the period and the frequency are reciprocals of each other. So, and we can also describe linear speed as 2 pi r over the period, right? Because we remember 2 pi r being the circumference of the circle, which is actually the total distance traveled when you make one revolution, and the time it takes to complete one revolution is the period. So we can describe this as its linear speed. And if you just notice, 2 pi over t equals the angular speed. So we can describe velocity as angular speed times r. All right. But then also, you should recall centripetal force and centripetal acceleration. So what that is basically the acceleration you need to be in a constant state of constant speed, but moving in a circle. So let me just bring up the circle again. So in circular motion, and in most cases, you maintain a constant speed, v. But you might say, well, if it maintains a constant speed, wouldn't the acceleration be zero? Well, that's true for the tangential acceleration. That would be equal to zero. But remember, velocity is a vector. So it has magnitude and direction. Or let me just like re-clarify that. So it has magnitude and direction. So even though the speed is the same, you see that the direction is changing. So we can define this as our centripetal acceleration. And because this object has acceleration, that means there must be a certain force acting upon it. And then we can recall from Newton's second law, force equals mass times acceleration. So we could say centripetal force equals mass times centripetal acceleration, or mass times velocity squared over r, which is right here. And this is how much force you need to maintain that circular motion. Say if you go too fast, then you're just going to keep going in that same direction because of Newton's first law. If it won't, because there's no other forces, it will just keep going in the same direction. If you have too much speed, it'll break out.